What's going on, everybody? We are going to be doing 9.4 today, so make sure you have your notes. And remember, yeah, if you have any questions, comments, throw them in the comment section on YouTube and all that fun stuff. I had the video myself. I'm super bored tonight, so yeah. So before we begin, I got some our logos here. Just got to put this one where it belongs and the trash. Oh, so sorry, guys. Okay, so let's go ahead and begin. So in the warm-up, what we're going to do is just review the domain and range really quickly. So if we look at this, the domain is all my possible x values, right? So you have this function that goes from here to here from my x values. Now remember, if it's a solid dot, it is included in the function. So right here, I got a -1 from my x value, and it goes all the way to +1. And since those values have a closed circle on them, I'm going to put these brackets. That just means it's included. Now the range is all my possible y values, okay? So if you look at your y values, it goes from -1 is where it begins, and it goes all the way up to +3. Once again, those are represented by solid dots, so it looked like -1, comma, 3, and we'd have the brackets. All right, moving on to the next one. Let's go ahead and look at this. Domain. Domain is all possible x values, and since I have this arrow, it's telling me I go on forever over here, and y, it's telling me I go up forever that way. But it's continually going on forever for both the negative infinity and positive infinity for my x values. So you can see that if this were to extend over and over and over and over, this would go all the way to negative infinity for my x values and positive infinity for my y values. Now the range, remember, it's all my possible y values. So if I kind of like look at this little bar right here, it's kind of saying, okay, let me go ahead and grab that really quickly. And all right, so then when I look at this, so this is just kind of indicating where does the y value start. It doesn't start until it hits the function right there at -1, okay? And then from there, it would also go on to infinity. So if I have it right here, I could actually, same idea, just represent that it keeps going up and up and up and up to infinity. So that will just look something like the range is -1 to infinity. Because once it starts here, it just keeps going up and up and up. Okay, next one. This one's a little different. We have basically x equals -y squared here, and how this would look like is domain is all my possible x values. So when you look on the negative infinity side, these are just going to keep going there forever and ever. Just as a quick reminder, guys, whenever it's going to positive or negative infinity, it's more of a concept than a number, so we always have a parenthesis and not a bracket, okay? And for my x values, it goes all the way to +2. And 2 is included in that function, so I would put a bracket. Now range is, remember, all possible y values, and it's slowly going to keep going all the way up and all the way down. So that would be all possible y values, which would be represented with negative infinity, comma, infinity. All right, so fourth one, I think this is the last one. This is a piecewise function. Piecewise function is just when you have multiple functions thrown into one graph here. So domain is all my possible x values. So we're going to take these step by step. So the first thing I'm going to do is look at this one. So my first possible x value is this 5. And it's a -5, and it's represented with a solid dot, so it is included in the function. And this keeps going, so if I go to -5, the next one is -3. So comma, -3, and that is not included, so I put a bracket. So then you notice there's a giant gap here, and then doesn't resume until -1. So what we're going to do is put a union symbol, just like a U, and right there I have it beginning at -1 and goes all the way to +4. It's an open circle, so I will put a bracket there. Now let's go ahead and look at the range. Range is all possible y values. It starts at -3. So put a bracket, -3. It goes all the way up to 2. and then it has a little gap from here to here. So then I would have it start at +4, and I'll put a union symbol. So +4 and all the way up to 5. Open circle, so I put a bracket. So hopefully, guys, that's a quick reminder of domain and range. Remember, range is just all possible y values, while domain is all possible x values. Okay? So let's go ahead now and look at the lesson. So it says for questions 5 and 6, graph each function over the indicated domain and then identify the range. Okay, so one more problem here. So I have this function. It's just a linear function, y equals, or f of x is equal to 1/2 x minus 5. So if I start at -5 and I just go, I want to go to my domain to +8. So I'd go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. So here's my domain. I don't want to go anywhere past 8. And my range, I'm going to go on the other side, and it's going to be -6. And I want you to realize there's a bracket there, so I'm going to put an open circle there. So I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. And I will just put an open circle there. And now I'm just going to go ahead and graph connecting the lines there. Do a little green. And we'll go here. Lightsaber sounds. All the way there. Okay. So let's go ahead. So that is my domain. Now if I were to talk about my range, once again, all possible y values, which basically just goes from here to about here. So that would be then -8, which is not included, all the way to +1. Nope, all the way to -1. And that is included, so it'd be represented with a bracket. Okay, and last one. This is very similar to this one. Same equation, but then I have a domain that's all real numbers. It goes to -infinity to +infinity. So same idea. I go to -5. I go up 1 over 2, up 1 over 2. And you can do the same, down 1 to the left 2, down 1 to the left 2. And then from there, what we'll do is just make a linear equation from here to here. And we will go, oops, and then I'll just drag that out from both sides as well. Boom, there's my equation. Now when you look at that, these would just go on forever on both sides. So since my domain is all real numbers, this would also, for a linear equation, make my range from -infinity to +infinity. All right. So now we're going to focus on the tortoise and the hare. A story that is really fake. A tortoise would lose in 2 seconds. Hares are very fast. Except that one YouTube video that actually shows that a tortoise would beat a hare. Calling shenanigans, though. So in the children's story of the tortoise and the hare mocks the tortoise for being slow, rightfully so. The tortoise replies, "Slow and steady wins the race." Not true. The hare says, "We'll just find out about that," and challenge the tortoise to the race. The distance from the starting line to the hare is given with the function of x is equal to distance equals time in seconds to the second power. Because the hare is so confident that he can beat the tortoise, and it makes sense in the math equation, it's going to give the tortoise a 1 meter head start. The distance from the starting line to the tortoise included, the head start is given by the function d equals 2 to the t power, which is meters in seconds. So, conveniently, 2 to the 0 power would give us 1, which represents our 1 meter head start. So at what time does the hare catch up to the tortoise? So let's check this out. We're going to make a little table. As a quick reminder, we got the hare. He has the function of 2 to the power, no, he has, yes, he has time, or x to the second power. In your notes, it's t. And we got the tortoise, who has the equation f of x is equal to the x power. So he has an exponential equation. So essentially, guys, what I want you to realize is we're going to be comparing a parabola to an exponential graph here. So let's go ahead and look at this guy. We got x, and then we got f of x, or we got d, and we got t. For you guys, so for you it should be t and d. And so if I looked at 0, 1, 2, 3, 4, 5, 6, so at 0 seconds, the hare would be 0. He hasn't started yet. At 1, it would be 1, 2, he would be 4, 3, 9, 4, 16. 5 to the second power is 25, and 6 to the third power is 36. Now over here, we'll go ahead and do the tortoise in red. We'll do green for our turtle. And we got same idea. Your note says D and T, so I'll do the same for this one, but you guys understand the difference between the two. So for time, for 0, 1, 2, 3, 4, 5, 6, what this would look like is 2 to the 0 power is 1, 2 to the first is 2, 2 to the second is 4, 8, 16. Let's see what we got here. To the fifth power, just 32, and then we got 64. Okay, so it kind of just shows you a little difference between the two. And if you guys remember what the graphs would look like, a parabola looks like this. We'll just say right there, and an exponential graph would look something like this. Okay, hard for me to draw that line, but better it'd look like something like this and goes up really, really quickly, okay? So let's go ahead now and look at this next part. It says at what times were they the same? So if I were to look at my notes or look at my tables, you would notice at 2 seconds, they both are at 4 meters. And also at 4 seconds, they are both at 16 meters. So at 2 seconds and 4 seconds, they are at 4 meters and 16 meters. All right, so let's go ahead now and bring up this next part. It says, if the race was very long, who wins, the tortoise or the hare? So really quickly, I'm going to bring up a Desmos graph. This just illustrates the two graphs. So really quickly, the red one represents the turtle, while the purple one represents other way around. The red one represents the hare, while the purple one represents the tortoise. So if you notice, the tortoise had a head start. He's going kind of slow. And then right here, the red parabola, this is where they intersect. That's where they first meet. And right here, the red one, the hare, is actually winning. But then the tortoise slowly gains up speed, and right here at 16, they're the same. And then anything after 16, the tortoise is actually going way faster at exponential speed, so on and so forth. So that just kind of illustrates the graph of what we are talking about as we're going through these next few problems. So when it says if the race is really long, who wins? The tortoise or the hare? So the tortoise will actually win. Because anything after 4 seconds or a distance of 16 meters, the tortoise has a much faster speed. And is ahead. Okay, so if the race were only 15 meters, so I'm going to do my best to illustrate this again. So if I were to have the hare, which was a parabola, positive domain would look like something like that. While the hare, his would look like this. Okay, and these 2 points represent 4 meters and 16 meters. So while the tortoise is going to go super duper fast after the 16 meters and always be ahead from that point, anything between 4 meters and 16 meters, the hare is actually winning. So right here, by looking at my graphs I put on Desmos, if the race were 15 meters long, who would win the race? That would be the hare. And why? It's kind of this illustration in my graph. So anything between 4 and 16 meters, the hare wins. And when I say between at 4 and at 16 meters, they're tied. So anything above 4 meters or below 16 meters, to be precise. So now what we're going to do is we're just going to look at this in interval notation, and we're going to look at average speed. So if you guys remember, whenever I looked at a curved line, you can't just figure out what the average speed is by looking at the whole graph. You have to look at specific intervals. So you could figure out what the average speed is between these 2 points, figure out the average speed between these 2 points, so on and so forth. So what we're going to do is basically look at the average speed of the tortoise and the hare on these 2 points and compare them. So if I'm looking at the tortoise, we're going to do all the tortoise and then we're going to do all the hare and compare those speeds. So for the tortoise, we're looking at time and distance, and we're just looking at the interval of 0, 1, and 2, and we're going to get the values of 1, 2, and 4. And what we're going to do is, remember, speed is just distance over time, so I'm just going to look at the change in distance over the change in time here. So I'm just going to look at these values. It's basically these points right here. So I'm just doing 4 minus 1, 2 minus 0, to get a average distance of 3 over 2 meters per second. From 2 to 4, same idea. Let's go back over here. I got time and distance. And then here I just have from 2, 3, 4. And my values in here were then going to be 8. Excuse me, no. They're going to be 4, 8, and then 16. Okay, so then same idea. Let's go ahead and look at here. 16 minus 4, 4 minus 2. This will just give me 12 over 2 to have a speed of 6 meters per second. And last but not least, let's go ahead and look at this one for the tortoise. We have time and distance from 4, and we'll just jump to 8. We don't have to do all those values. So if I plugged in 4 here, what that would give me then is 16. And then to the 8th power, let me just go ahead and take a calculator really quickly. 2 to the 8th power is 256. Let me see, 1, 2, 3, 4, 5, 6, 7, 8. Sure. 256. Now when I subtract these then, I'm just going to have 256 minus 16, which is 240 over 4, which gives it me 60 meters per second. All right, so you can see it's really going super faster in that interval right there. And remember, anything after 4 meters, the tortoise was going way faster. So now let's look at the hare. We're going to look at the hare for distance and time. And so we have 0, and if we plug in 0 here, 0 to the 2nd power is just 0. And if we plug in 2, 2 to the 2nd power is 4. And if we look at that, the hare was catching up to him, if you remember. So he was actually going faster right there. So when we see that, distance over time would just be 4 minus 0 over 2 minus 0, which gives me 2 meters a second. He's going faster than he is right here. Now, if you remember that one gap where they intersect, so when I had one looking like this and the other one looking like this, that's really bad. Let me go ahead and just bring it up here. When I look at on Desmos right here, this part from here to here is the next interval we're going. So we're using those points exactly where they intersect. So they should be the same. So let's go ahead and see if that is true. So if we go ahead and look at this at 2 seconds, this traveled 4 meters, and right here at 4 seconds it was 16. So then I would just have 8 over 2, which is equal to 4 meters a second. Excuse me. 16 minus 4 is 12 over 2, which is 6 meters a second. And then finally, on this last interval for time and distance, we had at 4 meters, it was 16 seconds. and at 8 meters, he's at 64 meters. So when I go ahead then and subtract those, I am going to end up with, what was that? So 48, which is 12 meters a second. And as you can see, the hare is much slower than the tortoise right there. Okay, last but not least, let's go ahead and look at this. So it's saying let's ignore this concept and pretend that these are not animals that we're looking at. We're just looking at the context of domain and range in this Desmos problem. And I'm trying to figure out when it is, just basically I'm comparing the two of them, okay? So when is one faster, what's the domain, what's the range, so on and so forth. So if I were to look at the Hare, which is intervals of increasing, so his was the parabola that looked like this, okay? So this is the Hare, and the intervals where he's increasing, well, it goes down, and then at 0, it starts to pick up. So remember, at a specific point on a graph, we can never tell if it is increasing or decreasing, so we'll always put a parentheses, not a bracket. So from 0 to infinity, he's increasing, while from negative infinity to 0, he is decreasing. Now remember, range is all possible y values, so what the range is it starts at 0, the 0 is included, and it goes all the way up to infinity. Now this does have a minimum point. It's the smallest point on the graph that it will be. So that would just be 0. So my minimum is 0, and it does not have a max. So we can write max is none. And I want to know when this animal was, when the parabola was, when did this graph have a faster rate of change? So I don't know if they're talking about the entire graph, just like without the context, but then they bring in the context right here. So let's pretend that there is no context. And if I just looked at these graphs, if this is the parabola, it's not increasing right here. So from negative infinity, it's not to 0, it's decreasing, okay? So therefore, obviously, even though the hare is going super slow, the tortoise is going super slow right here, it still has a faster rate of change of increasing because this one is decreasing. Well, from 0 to 2, though, it is going faster, and we saw that on our table. It had a 2 meters per second, while the other one was 1.5 meters per second. So when I look at this, the interval where it's increasing, that would just be from 0 to 2 seconds. Okay, so now let's go and look at the tortoise. The interval of increasing, well, if you look at the graph, the tortoise always kind of approached 0 but never touched it and then grew exponentially. So it's always getting bigger and bigger and bigger at a faster and faster rate. So it is always increasing from negative infinity to infinity. It is never decreasing, so intervals where it's decreasing, it's none or NA. So it's range, all possible y values. Now, while it approaches 0, it never actually touches 0. 0 is the actual limit as the function goes to negative infinity, okay? So when I look at the range, what it is, it's just from 0 to infinity. And it actually does not have any maximum or minimum points. Remember, while it approaches 0, it never actually touches it, so it's none. All right, next we're going to go ahead and just move me over here. And what we're going to do is, what we're going to see is the intervals where the animal is increasing at a faster rate. Well, remember, this guy, I don't know if they're talking about just the context because there's brought up animals in this one. But since the the parabola was decreasing from negative infinity to 0, I would state that this is increasing at a faster rate because it's definitely not, the other one's decreasing for sure. And then when we're talking about intervals like this, what we do is put our little union again. And remember, anything after 4 seconds, which resulted in the 16 meters, the hare was going much, much, much faster, okay? And one last thing, there's a little gap right here. Well, what's going on between 2 and 4 meters? This is actually where it was the same. We saw that in our graph, okay? All right, guys, so that's it. Hopefully that helps a little bit better. So that's all I have for you guys. If you have any questions, please let me know. And yeah, This is cool. We'll draw my new haircut. Miss you guys. Super bored. This is what I'm doing at 9:22 at night. So hopefully everything's going well. Stay healthy. Stay fun. Pacific Trails, you're the best. Carmel Valley, you're here too. It's okay. We'll let you stay. All right. Bye, guys.